So I hope everyone's doing well. It's been a few weeks since we've had a video going over some materials. So this next module, right, we're going to be discussing some of the mechanisms of an injury, some of the tissue repair process of an injury, and just kind of supplementing a lot of what's in the book and in the readings for the module itself. Right. And so when we talk about the mechanisms and what happens with an injury, right, we really need to define this or have a term for this. And one that is commonly used is trauma. And trauma being that we're having some sort of injury or wound, and it's some sort of internal or external force that is causing this wound. Right? And so the mechanical energy or the mechanical injury is going to result in some sort of change, right? In the state of a tissue, right? And the uniform motion of that matter, or in simplistic terms, when we talk about trauma or we talk about injury, we are going to be really limiting some capacity that we have to move, right? Or to do what we're really looking for. And so when we talk about these tissues, and specifically a lot of the soft tissues of injuries, so when we talk about muscle strains, when we talk about sprained ankles, if we talk about ligament damage, so like a torn ACL or a torn UCL, right? Those are the types of tissues that we're talking about here. And there's 4 properties to each of these. So there's a load that can be placed on these, and this is an external force that's acting upon or causing the internal reaction to the tissue itself. So when we place a load on somebody, this could be like placing a barbell on their back when they're working out, right? We're having an external force acting upon an internal body, causing reactions there. So we would have to stiffen up the muscle, we'd have to produce more force than normal to overcome this extra load or this extra resistance. Tissues are also going to have a innate ability to create stiffness, right? And to resist that load that we just talked about. So greater stiffness means there's a greater load resistance. Stress is the internal resistance to that load, where strain is a change in the length of that load. And where this becomes important, right, is that we can load a tissue in 7 different fashions. So we can have an unloaded condition, we can have where there's no strain or no stress being put on that tissue itself. So think about like if you're lying down, right, that your knee, the ligaments of your knee would not be stressed at all. They're unloaded. We can have tension, right? And what tension is where we are pulling on both sides, right, or both ends of a tissue. So we're trying to tear something or pull it apart. We can have compression where we are pushing down on it. So again, that idea of if we put a barbell on our back, right, our spine would be compressed or be pushing down. We have bending, which is a combination of tension and compression. So one side of the tissue would be having compression, while the opposite side, right, is having tension. And you can kind of think of this as if you're going to try to snap a pencil, right, an old wooden pencil. If we're going to push on it and snap on it, we're going to compress one side, and we would have tension on the opposite side. We can also have shear stress or shear loads. And we can think of this kind of as like a pair of scissors, where we're going to have 2 forces that are going to cross each other, right? And so we'd be cutting across that tissue. We can have torsion, right? Torsional load is a twisting. So kind of think about, right, if your foot is planted into the ground and then we twist, what happens to the knee, right? And then a combination loading is any other combination of these 2 things. So if we had tension and torsion being put together, that could be a combined load or a combination load, right? And that's our typical mechanism for a lot of our knee injuries, right? Is that combination loading of tension and torsion. So the next couple slides, right, it's going to go through these individually. The one that I really want you to focus on is tension, and that we call this a distraction force a lot of times. And the reason for that is if we think about when we get distracted in class or distracted watching this video, right? It's pulling our attention away from something. And what ends up happening here, right, is that we're going to be pulling the opposite parts away from each other, right? In the same, like we talked about before, compression is where we're going to push both ends together, right? So tension would be pulling away, compression is the opposite of tension, or we'd be pushing in towards one another. Right, we have our bending, which, like we talked about, one side being having compression, one side having tension. Our shear stress, right, blades of the scissors are cutting across, so we have forces acting in opposite directions. Our torsion, right, is our twisting, or that along the longitudinal axis, or think again, foot stuck in the ground and we twist. If we said I twisted my knee, what that would kind of look like. This all leads into this idea of a stress-strain relationship, in that tissues are going to have these different properties to them, right? And we can kind of think of tissues as a rubber band or some sort of cord or anything like that, or a hair tie, whatever you want to think about. So they're going to have the ability to stretch themselves out, right? But they're also going to have their ability to go back to their regular shape. So in this nonlinear toe region, we can kind of think of that as this cord, right? And that it's all kind of bound up, and we can pull on that cord to make it go straight, right? But there's no real internal stress being placed on it, right? But we can make it longer, okay? Now, when that cord gets stretched all the way out, at some point we catch a resistance or a stiffness to that cord or to that elastic band. And that's where we end up with this linear region, right? And the slope of that line is going to be our resistance to stretch, right? So as we go further and further, we create more internal loading. And at some point, we are going to no longer have a linear relationship. So the further we pull, the more internal stress that we have. What ends up happening is we have small tears, right? And if you go back and think about that rubber band, if you pull it over and over and over again, eventually it's not going to go back to its original shape. There's going to be little micro tears in that rubber band, or little spots where it's torn, right? And so it doesn't return back to its original shape. It's been stretched out. And that's what this plastic region is. And in the plastic region, being that we've had deformity or we've had change throughout, which is no longer allowing us to go back, where the elastic region we can stretch and we can go back. And then we have our ultimate failure point, which is where we fall into or a complete tear of that structure. And so this is, again, some terminology talking about stress and strain, right? And that what I hope that you get out of this is this idea of, when we think about tissues or we think about injury, where is that occurring and what's the mechanism to happening? And so in this nonlinear toe region, right, in the very beginning, we're just pulling that rubber band out. It's getting longer, but there's no internal tension to it, right? It's just taking the slack out of the rubber band or taking the slack out of the hair tie, right? And so we're pretty safe in that region. The same for our linear region, right? Or this elastic region, in that we can have these structures, right? So tendons, ligaments, muscle, skin, right? That are going to stretch, but then they're also going to go back and they're going to be able to change their shape. Now, each one of those tissues is going to have a different stiffness or a different ability to resist that, right? And again, we're fairly safe when we're in this region. When we run into our problems, right, is where we start getting into this yield point, right? And we start to see these micro traumas. And that elastic region is now gone, right? So the nonlinear toe region and the linear region make up the elastic region. We can stretch and we can go back. In the plastic region, we're seeing change, and this is where we get hurt, right? Or where we start to have functional issues. And when we say functional issues, this is where, maybe we don't get fully blown out knee or injury to that point. That'd be our ultimate failure point. But this is where we could have, a grade 2 MCL strain or MCL sprain, right? Or we start to see some sort of functional change. Maybe we don't have we get extra laxicity in the joint, or we're running into problems, is essentially what this comes down to, right? In that plastic region. So between the yield point where we see our micro traumas and our ultimate failure point, we've now seen a structural change in that tissue. So the ultimate failure point, right, is where now we can have a tear. So, we can think about this through a multitude of injuries. So, Kevin Durant or Aaron Rodgers, when they've torn their Achilles, you could see that, right? You could see that ripple kind of going back up into their calf muscle. And what that is they've stretched that Achilles tendon to a point, right, where it hits its ultimate failure point and it ruptures. In most tendons, right, fail at somewhere between 8 to 13% of their pre-stretched length. So where they are when they're relaxed, they get about 8 to 13% bandwidth before you run into problems. So when we think about adding mobility or doing stretching exercises or those sorts of tasks, whether it's in a warm-up, whether it's in the actual training session itself, right? What we're doing is we're looking for compliance or the ability of these tissues to get to longer lengths before injury, right? When we get really stiff, right, or we start to run into problems, that number is going to shrink. We're going to go closer to the 8 rather than the 13. And so this is a really kind of important idea when we think about the overall mechanism of a lot of our injuries, right? It's when we think about muscle tears or ligament sprains or tendons being torn or any of those types of injuries that are common in the athletes that we're working with, right? It's coming down to this overstretching idea, okay? And so the plastic region is a really important region when we think about the overall mechanism of injury. And so what can also happen, right, in terms of the properties of these tissues is that they can change over time. And when we talk about this progressive change over time, we refer to this concept as creep, right? And when we talk about creep, this isn't, the guy at the bar that's just being a creep, right? And staring and doing the things that he's doing, right? What we're talking about here is that a gradual change because of a constant stretch. And so the figure in this on the slide with it's trying to illustrate a little bit is we have a tree branch, and when we apply a weight to it, it's initially going to drop, right? And if we leave that weight on there, it's going to drop even further over the course of the day. Now, the kind of the trick to this, right, and what ends up happening to our bodies is the same thing as what's happening in this example. If we pull that weight off at 6 p.m., the branch is going to go back up a little bit, right? It's probably never going to go back up to where it was originally, right? But we're going to get closer to where we were at that 8 a.m. or when the weight was first put on. And if we do that every single day, right, the branch is going to maybe drop down a little further, but its rebound effect isn't going to be as high. Now, if we were to leave that weight on there for, let's say, 3 days or a week, right, we'd get a different change. When we took it off, maybe it doesn't go up at all. Right? And so this is the same idea as what happens with our tissues. So if we sit in a classroom or we sit at a desk all day, we get tight, right? Our muscles become tight. They're having a strain, or we're in a fixed position for extended period of time. So then it's hard to change that position. In the same idea, right, that can lead to injury. This is the exact same concept as what we're dealing with the tree, in that when we have those constant stresses being placed on us over time, right, our ability to rebound or have those elastic changes isn't there. Okay. So it's really important to understand that we can have these immediate, short, acute issues that can lead to our injuries, like what we see with Kevin Durant and Aaron Rodgers and even Kobe Bryant, right, with his torn Achilles and what happens there. Those are very acute, very quick, sudden ruptures, right? What we see in terms of potential for overuse injuries or for where we can end up having problems, right, is this idea of creep and this constant stress being placed on us. And so what that leads us into is this idea between traumatic and overuse injuries. And the nature of physical activities is going to change where or how injuries kind of occur, right? And when an injury is acute, it's usually something dramatic has happened, right? We're getting some sort of direct blow. So this could be, when we think about someone tearing their ACL or tearing an MCL or LCL, right? It's that direct blow coming in from a lateral or someone rolling up on them into their knee or their ankle, right? And then we could run into our problems there. The other issue or overuse issue, right, is this repetitive motion over and over again. So when we think about injuries that maybe a baseball pitcher would have or a tennis player would have, right, it's because of the repetitive overuse type of motion. Right? And that we're doing this all the same way in the same direction over and over and over again, and we can run into some problems. Right? So while we can have the acute injuries like what we saw with our stress strain curve, we can also have more overuse injuries, kind of like what we see with the idea of the creep concept. And so that's just an important thing to kind of understand. With that, that's going to wrap up our first video on mechanisms of injury. The second part of this, we'll go through some different types of injuries and talk about kind of what's going on there.